Good evening. So let me find my slide here, maybe. Okay, there we go, perfect. Lesson 6, the Big Bang and Scientific Laws. So thank you for making it back out tonight. This is really the last in the set where we look at evolution specifically. Now we'll continue to touch on evolution and some of these thoughts as we work through our various lessons, but tonight is really the sort of the end of looking specifically at evolution. Last week we looked at macroevolution. Again, this week we kind of tie it all together with the scientific laws and the Big Bang. And really, it's even a broader topic, or a more specific topic, really, the scientific laws that the Big Bang violates. And then we move into next week, 6 literal 24-hour days, question mark. We'll really look at the account in Genesis and move beyond there at the creation account when God created all things. And then we move into a series of what will be probably 3 parts, and that's evidence from the creation on its age. And we'll look at a number of different things over that 3-week period. So again, we've started all of these with this definition about science, and so I'll bring it back up tonight. Knowledge about the natural world that is based on facts, learned through experiments and observations. So again, what I'll ask in the end tonight is this scientific? And I'll let you guys answer that. Tonight it will be part review and partially new material. Now the reason it's part review is because some of the things we talked about the first night with the Big Bang are fairly deep, complex, maybe even confusing things. And so hopefully it'll give us a chance to work through them again, and then we're going to advance it as well. So some will be review, but some of it will be new material. I just want to make sure that you're able to talk to folks about the Big Bang. And for the group of young people sitting here, I want you to be prepared to engage folks in college. I want you to be able to ask thought-provoking questions of your professor or your friends. And so I want to prepare you for what lies in front of you. We looked at this video the first time we looked at the Big Bang. It's real short, but again, this is their explanation, so we'll look at it one more time tonight. And this is from National Geographic.
But what's amazing is that in the entire universe, nothing is more powerful than the colossal explosion that created it all, the Big Bang.
The Big Bang is an amazingly difficult thing to wrap your brain around, which isn't surprising. When you're trying to think about the universe being smaller than the head of a pin,
actually smaller than an atom, about as small as the proton at the center of an atom. Whatever the universe was at the very beginning, some 13.7 billion years ago, we think it was tiny, an infinitesimal nugget of space. And then something happened, triggering the most colossal explosion in history. In a billionth of a billionth of a billionth of a second, the universe grew from the size of that tiny point to something billions of miles across. This colossal blast created everything, all the matter we see in the universe today. And it did all this without even making a sound.
When one sees the Big Bang portrayed in a film, there's always a big bang, a noise. Of course, that's silly because sound doesn't propagate in space. But what's often overlooked is that the Big Bang is not just an explosion that happened at some moment in time at some point in space.
it was not just an explosion of material into an empty universe that was sitting there waiting to be filled. It was the explosion of space and time into existence to begin with.
And that's what trips most of us up. Before the Big Bang, there was nothing, literally nothing. And the black void of space is something. So is time.
To ask what's before the Big Bang, what's before there is time, is really a meaningless question. And likewise, to ask where the Big Bang occurred is meaningless because there was no space.
Okay, so we won't go back through all the ridiculous thoughts that were in there about we're not allowed to ask what was before the Big Bang. We're not allowed to ask where the Big Bang occurred. So we'll just skip that, but I do want to remind you of a few things. This is from Discover Magazine. You can see the caption there, where did everything come from? And they have a picture of the universe at, some 0.0000 after it started. And then the caption at the bottom, the universe burst into something from absolutely nothing. Zero. Nada. And as it got bigger, it became filled with even more stuff that came from absolutely nowhere. How is this possible? Again, a great question. Ask Alan Guth. His theory of inflation helps explain everything. Okay, let's ask Alan. Here's Alan writing for the Scientific America. The observable universe could have evolved from an infinitesimal region. By the way, that's a dot. It's then tempting to go one step further and speculate that the entire universe evolved from literally nothing. So again, what they're teaching is that nothing exploded and created the everything we see in the universe today. The 100 octillion stars and associated planets, all from literally nothing. This is the evolutionist timeline. The Big Bang 13.7 billion years ago, the first stars around 13.2, galaxies forming in the 11 to 8 billion year area, our Milky Way somewhere in the 9 to 7 billion year area, and Earth 4.5 billion with life, the first single-celled form of life, which we talked about last week, 3.5 billion years ago. Now, as we talked about this timeline has already collapsed in on itself. We're finding galaxies now out to the point, according to Big Bang distances, that are already where stars should just be forming. And we're already finding intact, complete, complex galaxies. This thing is completely off the rails. This next video clip is from Spike. Again, a quick reminder about the topic of the missing mass according to the Big Bang theory.
First of all, there are indications that there might be some stuff in the universe that we can't see. For example, many galaxy clusters don't appear to have enough mass to hold themselves together gravitationally. When this was first discovered, astronomers called it the missing mass problem. Another example is seen within individual galaxies, where stars move around as they orbit the galaxy's center of mass. However, in many galaxies, the outer stars are moving too quickly for the galaxies to hold themselves together over long timescales. Again, it was proposed that there's a lot of missing mass somewhere to hold them together. Most astronomers today believe that these observations indicate that there is actually mass there to hold these structures together. They believe that this mass isn't really missing because it's there. It's just that we can't see it. But if these observations were actually caused by mass that we can't see, how much of it would there be? A lot. Almost 6 times as much as the visible mass. For every galaxy you see, there would be almost 6 galaxies worth of stuff that you don't see. In other words, only 15% of all the physical stuff in the universe would be visible to us. The other 85% would be invisible. This invisible mass has been named cold dark matter. Matter because it's physical stuff, cold because it's moving at slow speeds, and dark because it's invisible. Now, when I say it's invisible, I'm not saying we can't detect it because it's too small or too dark to see. No, it's invisible in its very essence. It emits no visible light, no X-rays, no radio waves, nothing. Nor does it absorb any light or reflect any light. In fact, it doesn't interact with light at all. That's why it's invisible, because light and all other forms of radiation would pass completely through it. This is only one possible explanation, though. There are several other explanations, some of which don't even require there to be any missing mass at all. They account for the observations in other ways. But most secular astronomers reject all these other possibilities. Why? Because they don't fit the Big Bang model. So, because most secular astronomers believe in the Big Bang, they must believe that the missing mass is made up of cold dark matter, an exotic new form of matter that's not made up of atoms, but some other particles that are invisible. Matter like this would be outside of known physics. That's why you'll see astronomers frequently make comments like this one. What exactly is it? What is it made from? Well, the simple answer is, we don't know. No known particle fits the description. And as a Princeton cosmologist has commented, it's an embarrassment that the dominant forms of matter in the universe are hypothetical. Even though there are no good theoretical candidates for dark matter particles, Many physicists have been looking for them anyway. So far, the searches have been unsuccessful.
So this is a journal article from sci.org, The Search for Dark Matter. You can see this box down here, and I'll blow that up for you. It says, unlike X-rays that the naked eye can't see, but equipment can measure, scientists have yet to detect dark matter after 3 decades with the world's most sensitive instruments. Now, I want to put this in perspective for you so you kind of get the picture here. They believe this dark matter surrounds each of the galaxies almost like a lattice formation that holds the galaxy together. And yet we've been trying to find one particle of dark matter for the last 30 years that's supposedly 85% of the matter, and we've not found one particle. I have an idea why quite possibly we have not found one particle of this supposed dark matter. This article is from the end of last year, November 2017. Dark matter hunt fails to find elusive particles. No kidding. If you blow this up, guess what it says? Physicists begin to embrace alternative explanations for the missing material. They're not going to find dark matter. They've spent 30 years looking for it. It's not going to happen. So in summation, according to the Big Bang Theory, 85% of the matter in the universe is made up of this exotic matter, which is not protons, neutrons, or electrons, and yet we've never found a single particle in spite of lots of research time and very complex instruments over the last 30 years. 85% of the gravity of the universe, according to the Big Bang and according to dark matter, is coming from something which we know nothing about, which the Big Bang knows nothing about, other than to name it. Lastly, we really don't have any idea when it came or even where it came. If you remember, according to the Big Bang, the Big Bang itself created what? Hydrogen, helium, and trace elements of lithium. Notice what we're not being told was created: dark matter. And there's no explanation for when it was created, other than we have to have it in the formula to make the formula work. So in summation, I would say this about dark matter: it is unscientific. The next clip is a quick review on dark energy, another one of these dark side chameleons, again from the same video series.
Along with dark matter, there's more in the universe about which the Big Bang model knows nothing. A lot more, in fact. In the late 1990s, astronomers were studying some faraway supernovae. Supernovae are enormous explosions in space that occur under certain circumstances. For example, if a white dwarf star pulls material off of a companion star, it can only do this until a critical threshold is reached. At that point, the white dwarf quickly explodes in a massive, violent catastrophe. Anyway, astronomers were studying these supernovae, and they discovered something unexpected. The astronomers calculated the distance of the supernovae by measuring the brightness of the explosions. Then they calculated the distance that the Big Bang model predicted based on the redshifts, and the distances were slightly different. What does this mean? Well, according to the Big Bang model, this means that not only is the universe expanding, but the expansion rate is also accelerating. In other words, it's not only getting bigger, it's getting bigger faster and faster. According to the Big Bang model, all of the space in the universe must be filled with some kind of anti-gravity energy, driving the universe into expanding faster and faster, even though mutual gravitation among all the galaxies would otherwise prevent this. The Big Bang model requires a tremendous amount of this energy, filling the entire universe and growing as the universe itself expands. So what is this mysterious anti-gravity energy that the Big Bang model requires? It's become known as dark energy, not because it's something that looks dark, but because it's similar in some ways to the concept of dark matter. Just like dark matter, it's outside of known physics. Nobody has ever seen any, and nobody has any idea of what it could possibly be. Earlier we saw that secular cosmologists believe that 85% of the physical stuff in the universe is invisible cold dark matter. But this invisible dark energy would be about twice as abundant as all the physical mass is, about 68% of the total mass energy of the universe. As an article in Astronomy magazine explained, to get enough oomph, that's a technical cosmological term there, to drive the present acceleration of the universe, dark energy must make up about 68% of the total density of the universe. The biggest problem with this idea is that no one has any idea what dark energy is. So far, all we've been able to do is name it. So what exactly is dark energy? The obvious answer is, again, we don't know. Actually, the situation is even worse. We really don't know. Although cosmologists have adopted a cute name, dark energy, for whatever is driving this apparently anti-gravitational behavior on the part of the universe, nobody claims to understand why it is happening, or its implications for the future of the universe and of the life within it, despite thousands of learned papers, scores of conferences, and millions of dollars worth of telescope time. The nature of dark energy is now perhaps the most profound mystery in cosmology and astrophysics, and it may remain forever so. Let me repeat, we don't actually observe any dark energy in the cosmos. The only things we observe here are the brightness of the supernova explosions as seen from Earth, and the redshifts that we measure in the light. So dark energy is not something that's observed. It's just an interpretation of the observations that's required by the Big Bang model. So once again, the Big Bang model requires something that is completely outside of known physics. In this case, anti-gravity energy. And once again, the Big Bang model has no explanation for what it is or how it formed.
So again, dark energy isn't necessary. What's happening here is to make our observations of the light fit the Big Bang model, we need this anti-gravitational energy that's really expanding the universe faster and faster as it goes out from us. So now, what we observe when we look in space around us is most of the galaxies that we observe are redshifted. That means the light is shifted more to the red side of light. That indicates, we speculate, that they're moving away from us. So it's like Doppler effect for light. And very few galaxies are actually blue shifted, indicating they're moving in any way towards us. So what we see around us is galaxies moving away. The Big Bang theory demands that they're moving faster and faster based on that redshift, therefore demands the existence of dark energy, which has never been detected. And we're now to the point where dark energy and dark matter supposedly represent 94 to 95% of the entire universe. In summation, please keep in mind we do not need dark energy except to make the Big Bang theory work with observations. We are now to the observed point that the universe we see and measure is 4% of what's really out there. And lastly, again, the Big Bang created hydrogen, helium, small trace elements of lithium. When did the dark energy get created? It's not part of the formula. We don't know what it is or when it was created. In summation, dark energy, like dark matter, is truly unscientific. This next one is inflation. Two quick video clips, one from Evolution's Achilles' Heels that's followed right up with one from What You Aren't Being Told About Astronomy.
But the Big Bang, in fact, has its own light travel problem. This has to do with the cosmic microwave background radiation, which is supposedly the afterglow of the Big Bang, and which has been observed to have a very uniform temperature no matter where you look in space. And there just hasn't been enough time for the energy to be transferred across space to make all this temperature uniform to the extent that it is. And that's called the horizon problem.
Now, there was an interesting explanation or attempt to find a solution to this, and it's called the inflationary period. So some incredibly short instant after this initial Big Bang, the universe expanded by massive orders of magnitude, and then somehow this period of inflation, as it's called, stopped. So it starts for no particular reason, and it stops for no particular reason. And by the way, during it, gravity has to work in reverse. So rather than matter being attracted to matter, it has to repel it. And so there's this amazing story is told to try and patch up this glaring problem that the Big Bang has.
The inflation proponents have no good physical model for this faster-than-light expansion. It's a fudge factor. But the Bible teaches several times that God stretched out the heavens. The uniformity of background temperature is consistent with the universe being upheld by a single creator outside time and space. Furthermore, it's not just a God did it explanation. Creationist physicists have developed multiple competing models of this expansion using Einsteinian general relativity.
cosmologists have no explanation for how inflation could have occurred. There's nothing in physics that can explain this process. Supposedly, inflation was driven by a particle called an inflaton. But has anybody ever seen an inflaton? No. Is there any room within particle physics for an inflaton? No. Is there any justification for believing in the inflaton, or inflation overall, other than the fact that the Big Bang model needs it? No. As one physicist admitted, inflation's theoretical underpinnings may be rather tentative. The inflaton, after all, is a hypothetical field whose existence has yet to be demonstrated. And as an article in Astronomy magazine explained, what drove inflation? Nobody knows. Physicists have suggested different models to describe the inflating universe, but all the solutions are mathematical conveniences with no particular physical basis. All the theories of inflation amount to proof that we don't have one good theory yet, says this astrophysicist. So inflation is the name given for a hypothetical process that's never been observed, based on a hypothetical particle that's never been observed, and that has no basis in physics. But according to secular cosmologists, even though inflation has no basis in physics, it must have happened, because otherwise the Big Bang model would be falsified. And we know the Big Bang model is true. See the reasoning here?
I see the reasoning. Makes perfect sense. Okay, so keep in mind the Big Bang theory didn't have dark matter. That came later to get the theory to align with observations. Did not have dark energy. That came later to get the theory to align with observations. Did not ever have the idea of this faster than light inflationary period where physics were set aside. That came because the cosmic background radiation, the CMB, cosmic microwave background radiation, when measured, did not indicate what the Big Bang had initially said it should. And so rather than throw out the theory, they just added this faster than light inflationary period where in a millionth of a second, the whole universe expanded billions of miles across so that they could then say, see, it matches what we observed. Keep in mind, it was added later. So in summation, the supposed inflation particle, the inflaton, is not supported by particle physics, thus not supported by physics or science. Inflation started and stopped for no reason. So we have to set aside the scientific laws we know to get inflation to start and keep them set aside and get it to stop for reasons we can't explain. Faster than light inflation is unscientific and is only needed to make the Big Bang model fit observations. In summation, I would say inflation and the inflaton particle are unscientific. So this next video clip is from Spike again, and here he's going to talk about the law of conservation of mass and energy, a physics law.
In addition to not actually being allowed by physics, the Big Bang model goes much farther and also violates some of the most important laws of physics. Probably the most fundamental idea in physics is that energy and matter are conserved. In other words, energy and matter cannot be created nor destroyed. Physicists have known for some time now that energy and matter are interchangeable. For example, you've probably heard of Einstein's famous equation E equals mc squared. The E stands for energy, m stands for mass, which is the amount of matter or physical stuff, and c is the speed of light, which is a very large number. So a lot of energy is contained within a small amount of stuff. And we can convert matter to energy. The most efficient way we know how to do this is in a nuclear explosion. A small amount of stuff releases a tremendous amount of energy. We can also go the other way and convert a lot of energy into a small amount of stuff. We do this in particle accelerators. Tiny particles get accelerated to almost the speed of light and then get smashed together. More material comes out of those collisions than went in. The particles' kinetic energy, the energy contained in their motion, gets converted into matter. So again, we can convert matter to energy and energy to matter, but we can never destroy either one, and we can never create either one. This is called the law of conservation of mass energy, because the total combined amount of mass and energy in the universe never changes. We can only convert them back and forth. This law is one of the fundamental, foundational laws of science. As one of my physics textbooks says, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. We see this law's effects every day in our lives. Why do you need to eat food, regardless of how difficult that task may sometimes be? Because your body can't create energy from nothing, so it needs to get it from the chemical energy stored in the food. Why do you need to pump gas into your car? Because your car can't create kinetic energy, the energy of motion, from nothing, so it needs to get it from the chemical energy stored in the gasoline. Why do you get a bill from the electric company every month? Because the electrical devices in your home can't create energy from nothing, so they have to get it from the electric company, which also can't create it from nothing. It gets it from coal or natural gas or some other source. In fact, you couldn't be watching this video if this law weren't true, because you're watching it on an electronic device. And some of the principles of electronic circuit design are based on this law. Again, this law is very fundamental, but the Big Bang model violates it on the largest possible scale, a universal scale. It says all the energy and matter contained in the entire universe was created from nothing. Therefore, the Big Bang contradicts physics in the most fundamental way possible. Are cosmologists aware of this problem? Yes. Some try to avoid it by claiming that the universe actually consists of balanced amounts of positive and negative energy, which all add up to zero. In other words, even though the universe looks like something, it's actually just nothing. Therefore, they say, on a net basis, the Big Bang didn't really create anything, so there's no problem with physics being violated.
Very similar to this, and I just want to say it because you may have heard this one as well. The first law of thermodynamics is for a thermodynamic system. It's really the same law. Matter or energy cannot be created or destroyed in a thermodynamic system. The universe is a closed thermodynamic system. And so the same law is violated here, the first law of thermodynamics. Now, I do want to give the other side a chance to respond to this point. And so here's the response from physicsoftheuniverse.com. The Big Bang does not address the creation of the universe, only its evolution. What? Okay, whatever. And the laws of science break down anyway as we approach the creation of the universe, so there's no reason to believe that the first law of thermodynamics would apply. So since we don't really have the laws in the start anyway, they break down according to the physics of the universe, we really haven't violated the law at all. There's the answer. Or how about this one? If the universe appeared spontaneously in an empty space-time, it would not violate the first law of thermodynamics if the universe has an overall energy of zero. Now wait a minute, we were just hearing about 68% of the universe is dark energy, and now we're hearing about, don't worry, the energy overall is zero. Well, let's keep reading because that makes no sense at all. Strange as it may sound for the universe to have zero total energy, and that does indeed sound strange. It may be true, the gravitational energy of the universe is negative quantity, which may balance the rest of the energy in the universe, leaving a net balance of zero energy. Okay, just the dark energy alone exceeds all the gravitational energy, point number one. Point number two, where did we get this idea that gravitational energy, whatever that is negative energy of some kind? That's ridiculous. So I do want to say something in summation here. I have a word of the day desk calendar that a friend gave me for Christmas this year. And the word of the day on January 25th, I think, is appropriate here. Bamboozle. So I'll read this to you. To deceive by underhanded methods, dupe, hoodwink, to confuse, frustrate, or throw off thoroughly or completely. That type of answer is an attempt to bamboozle. That is not a meaningful answer, nor a scientific one. I would say again, the Big Bang Theory violates the first law of thermodynamics. It violates the law of the conservation of mass and energy. So the Big Bang clearly violates the laws. It's unscientific. But the Big Bang also violates the second law of thermodynamics, at least a part of that law, namely that everything in a thermodynamic system tends toward disorder, tends toward chaos. In fact, we know this to be true. We look at our cars and we see this to be true. We look at our computers and we see this to be true. We look at a home, a building that's left, we see this to be true. It's true for biological systems. We know this to be true. I don't mean to be disrespectful, but this is Sue at 20. This is Sue at 90. This is Sue at 3,000, right? We know this to be true. Sue is tending toward total disorder. So is Rich. Until the Lord returns, this is where Rich is headed. And it's true for all biological life until the Lord returns. We're not moving, getting better and better. We're devolving. The evolutionists will postulate, well, don't worry, if we add energy to an open system, it will overcome the second law of thermodynamics. Good news, don't worry, Jay, we've got this figured out. Well, there's two issues here. Number one, the universe is not an open system. It's a closed system by definition. But adding energy, just simply adding energy, is extremely destructive. It's never constructive. Let me give you some examples. Unless you have a very complex way to harness and use that energy. But just simply adding energy to the mix, you can add the energy, son, to the roof of your home, and it will start to degrade. If left alone, your home will start to degrade. The vinyl top on your car will degrade. The upholstery would degrade. The clear coat on your car will degrade. Adding energy is not going to stop the second law of thermodynamics. In many cases, it's going to speed it up. In fact, unless you have a very complex system that can harness that energy and use it, something like chlorophyll that's found in a leaf, energy is very destructive. So the question, to sort of frame it, because order has increased in a closed system, which means entropy has decreased, doesn't this violate the second law of thermodynamics? That's my question. That's our question. Well, we need to hear their answer. So here it is. Because the universe is expanding, it keeps getting shifted out of equilibrium and in a drive to reach a new equilibrium state. You can get pockets of order occurring without violating the second law because the maximum allowable entropy also keeps increasing. Okay, now wait a minute. We started with hydrogen and helium and a little bit of lithium, and we're up to 100 octillion stars, and we have not increased complexity? You must be kidding me. Again, I would like to respond to this in summation. I would like to tell you about a desk calendar I have. Yeah, again, this is an attempt to bamboozle. The Big Bang Theory violates the second law of thermodynamics, clearly. But it's more than just that. It's genetic entropy. And this we know to be true as well. This clip is from Evolution's Achilles' heel.
Yet, when you consider humans only, it is staggering how similar we all are one to another. And if you exclude recent mutations like sickle cell anemia or hereditary blindness, all those bad things, it would be possible to put all the world's human diversity into a single original human couple. But there's a problem, and it doesn't matter if you're looking at the human genome or the chimpanzee genome or any other genome. And the problem is that the information is degrading and mutations are building up in populations over time.
So I've been studying genetic entropy for the last 13 years, and it's a really profound problem, and it's something widely acknowledged by geneticists, and it is the problem that bad mutations accumulate in the human genome. And this is best illustrated by just considering it on a personal level. In your body or in my body, we have about 3 new mutations every time a cell divides. So this is sobering because it's the reason we die. And so the reason that we get old and all of our systems start to break down is because of this mutational process and the accumulation of bad mutations in our genome. It's why there's an upper lifespan. Now, the problem is bigger still. Because of course we already know that we're mortal, but we transmit a certain fraction of our mutations to our children, and they add more mutations to it, and then they pass it on to their children, and then they add more mutations still, and they add it to the next generation. So this is a problem not just for people, but for the whole human race. And logically, the human race should be devolving, not evolving. Basically, the human race is degenerating. The human genome is rusting out like a car.
Can natural selection solve this problem? No. Think of a room full of people. Now, kill off only the ones with the worst or most obvious mutations. What do you have left? A room half full of people that still have 60 to 100 more mutations than their parents. If everyone is multiply mutant, and if every generation is more mutant than the one before it, all selection can do is slow down the degeneration by killing off the absolute worst of the lot. But it doesn't stop mutations increasing the population over time.
So genetic entropy is profound. Not only is it profound because it really impacts us personally and our children and our grandchildren, It's really profound because it is lethal. It is absolutely lethal to genetic evolutionary theory, because it means that things are going down, not up.
All modern scientific evidence points to the decay and destruction of an original good design. If you like, good information getting worse. But where did this good information come from in the first place? How did life begin? Even under an evolutionary scenario, the first cell would have to have been horrendously complex.
You see, genetic entropy is exactly the opposite of what evolution would predict. Evolution would predict it's getting better and better and better. But what we're seeing is a perfect design that's picking up more and more mutations over time. The exact opposite of what we should find if evolution is true. So I would ask the question, is the Big Bang Theory scientific? It's yours to answer. One more problem, and the problem gets a little bit worse. Actually, it gets much worse, but I want you to see it. The entire creation, not just the sun, not just the moon, not just the stars, the entire creation gives evidence of very, very, very tight, how would I say it? I'm on the wrong slide. Let me get where I'm going. Fine-tuning. I was reading the wrong slide. So I want to end on this video clip. Our creation gives evidence and proof of extremely complex tuning. And so I want you to hear this from Spike.
The Big Bang model is supposed to explain how the universe got here without any sort of intelligent creator being involved. Supposedly, the universe just happened. If that were true, then you'd expect the universe to look like the outcome of random natural processes. You wouldn't expect the universe to look extremely fine-tuned, but that's exactly what we see. Now, entire books have been written on how well-designed and fine-tuned the Earth is to support life. Some of these are even from secular authors. In the previous video in this series, we also talked about how well-designed the sun is too, and how none of this should surprise us, because the Bible says that the Lord created this world for us to live here. Secular astronomers, though, have no explanation for this. All they can say is that if the Earth weren't a suitable home, we wouldn't be here to observe it. Obviously, this isn't a very satisfactory explanation. It turns out, though, that this problem is bigger than the Earth and Sun. Far bigger, in fact. The entire universe appears to be fine-tuned for us to be here. This extends beyond objects like planets and stars, into the very fundamentals of physics itself. Many of the laws, forces, and constants of physics have very fine-tuned values. If you change them even slightly, the universe would be vastly different, and we wouldn't be here to observe it. As famed cosmologist and atheist Stephen Hawking has written, a change of as little as 0.5% in the strength of the strong nuclear force, or 4% in the electric force, would destroy either nearly all carbon or all oxygen in every star, and hence the possibility of life as we know it. Change those rules of our universe just a bit, and the conditions for our existence disappear. Most of the fundamental constants in our theories appear fine-tuned, in the sense that if they were altered by only modest amounts, the universe would be qualitatively different, and in many cases, unsuitable for the development of life. For example, if protons were 0.2% heavier, they would decay into neutrons, destabilizing atoms. Our universe and its laws appear to have a design that both is tailor-made to support us, and, if we are to exist, leaves little room for alteration. That is not easily explained, and raises the natural question of why it is that way. Many other scientists agree with this. There is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. It is fine-tuned for the essential building blocks and environments that life requires. This fine-tuning extends even to the features of individual atoms. As astrophysicist Sir Fred Hoyle, who is not sympathetic to creationism, wrote, "Some supercalculating intellect must have designed the properties of the carbon atom. Otherwise, the chance of my finding such an atom through the blind forces of nature would be utterly minuscule." A common-sense interpretation of the facts suggests that his super-intellect has monkeyed with physics, as well as with chemistry and biology, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. Now, to be clear, many of these fine-tuning arguments are based on the Big Bang model. Obviously, I don't accept the Big Bang. But it's fascinating that the Lord created the universe in such a way that even a theory designed to deny His creation still makes the universe look designed and extremely fine-tuned. As one physicist wrote, life appears to depend upon delicate coincidences that we haven't been able to explain. Another said, our own universe is an extraordinary place that appears to be fantastically well designed for our own existence. This specialness is not something that we can attribute to lucky accidents, which is far too unlikely. The apparent coincidences cry out for an explanation.
So a large number of items in the cosmos appear to be fine-tuned. Amazing preciseness. And again, that's not Rich speaking. That's many scientists, and many of them not Christians and not sympathetic to Christians, just looking at the evidence. So tonight, God's version of the story. 4 quick points. I think we've been practicing Genesis 1, right, Pastor? The 10 words, in the beginning, God created the heavens and the earth, right? If we were to go to the book of John, we would learn that in the beginning, the Word was with God, right? And He was God. The same was in the beginning with God. All things were created by Him, and without Him was anything made that was made. So we learn from John that Jesus is the one who, in the beginning, the second person of the Godhead, created all things. Here, Paul picks up that point in Colossians chapter 1, and he says this, for by Him, that's by Jesus, were all things created that are in heaven and in earth, visible or invisible. Whether they be thrones or dominions or principalities or powers, all things were created by Him and for Him. And He is before all things, and by Him all things consist. So let me give you my 4 points. Notice point number 1, all things were created by Him, by Jesus Christ. He's the creator of all things. Next, they were created for Him. A friend and I were talking, and the discussion was the existence of aliens. And he was arguing that they existed. I was arguing that they did not exist, and I was giving evidence why. And he came to this conclusion. He said, Rich, I have a problem. There's no way we can look at this entire universe and just come to the conclusion that God created all this just for us. And I said, there's where you've missed it. He didn't create it for us. He created it for Him. He created it to bring glory to Him. It was meant to shout His glory, not to entertain us. Next, all things were created by Him, they were created for Him, and He is before all things. Now, obviously, Jesus Christ existed before He created everything, but it means more than that. It means that He is the preeminent one in all of creation. He is before all things. No matter where you drill down in creation, you will find the preeminence of Jesus Christ. In fact, Paul goes on to make that very point. And then finally, it says this, and by Him all things consist. Here's the Greek word. It gives this idea. All things are being held together. So as we look out at the universe, in fact, if we just dive in and look at an atom, and we talk about the electrical force and the strong force that's holding this atom together, Paul would remind us, no, it's not just that. It's the Creator. It's Jesus Christ who's holding all things together. Maybe we would look at laminin, the glue that's holding our cells together. And Paul would say, yeah, that's true. Laminin is holding our cells together. But guess what? It's actually Jesus Christ that's holding all things together. Or maybe we would talk about the gravity that's holding our solar system intact. And Paul would remind us, yeah, that's true, but Jesus Christ is the one who's holding this whole shooting match together. Now, I'm not the preacher, I'm just the teacher, but I will make a point by way of application before I turn it over to Pastor. If Jesus Christ can hold this entire universe together, I would like to present an idea. I bet He can hold your life together. I bet He can take care of you. I bet the one who holds the stars in place and knows them all by name, hasn't lost a single one. I bet He can hold our life together as well. Thank you.